The title of today's webinar presentation is Reducing Travel with Robots and Digital Automation. My name is John Schriefer, and I'm going to be moderating this presentation, including the Q&A. Our presenters today are Justin Ritter, who's Director of Project Engineering at Lucas Systems, and Ron May. Ron is Lucas Systems' Principal Engineer. Now, before I turn things over to Justin and Ron, I just wanted to very quickly go over the agenda and an idea of what we're going to cover in the next 20 minutes. The general idea behind this presentation is to describe solutions that address the DC labor productivity challenge, and in particular, new technologies and strategies to reduce DC travel. As most of you probably know from your own operations, travel time typically represents a significant portion of total labor time. By some estimates, warehouse workers spend much more time walking than they do almost anything else. So in the course of the next 20 minutes, Justin and Ron are going to provide a quick overview of the traditional approaches to reducing travel, and then they're going to spend more time delving deeper into two classes of newer technologies to address the travel challenge: robots and what we're referring to as digital automation. And by that, we mean software and math-based optimization engines that don't require any new physical infrastructure. So with that, let me turn things over to Justin Ritter.
Thanks, John. As John mentioned, travel makes up a significant part of the warehouse associate's day, especially in picking, which happens to be the most labor-intensive process within the DC. The goal of continuously reducing costs and distribution makes picking an attractive area to focus for any improvement. The diagram on the screen shows the difference between an RF process and a voice-directed process. While some of the RF-specific steps can be eliminated or reduced through voice direction, it does not address the travel time at all. This is what we call the travel challenge. Process optimization is a step above voice enablement and is an area that Lucas focuses on. A very familiar idea to anyone who's worked in process improvement or Lean Six Sigma. How can you organize the work in a more intelligent way to minimize the overall effort to get it all done while maintaining quality? There are a few examples on the slide. One example is zone picking, separating work across zones and then merging it at a packing station to minimize travel for any one user and improve throughput. Another example is interleaving work, taking advantage of the fact that an associate has empty forks after putting product away in racking and is capable of taking a full pallet within the same aisle to the dock. This eliminates some of the travel required before the pick if it was done in isolation. For today's presentation, intelligent batching is where we'll spend a lot of our time today. It's no secret that if you can move from single order picking to multi-order picking, you can reduce the overall number of trips through the warehouse, and as a result, cut significant portions of travel time out of an associate's day. Of course, there are other solutions to the travel challenge, including various mechanical automation solutions. I'll now hand off to Ron to talk about these.
Thanks, Justin. Different forms of mechanical automation address different aspects of the travel problem. Mechanical conveyors and belts are one traditional approach to the travel problem. However, they can be expensive to reconfigure, take up valuable space, and typically limit how associates can move within the warehouse. Picture the ladders and steps to get in and out of zones of conveyors. Goods demand systems, whether based on traditional ASRS type technology or the newer AMR type, which is shown there at the bottom, is what's in use at Amazon, are still typically expensive and not appropriate for smaller DCs or those picking a mix of products. Swarming robots, the latest solution, still require people walking in aisles. Typically, those solutions optimize the throughput per robot, not throughput per person hour. There are even swarming conveyors being developed and deployed that can dramatically be dynamically combined to move products in the warehouse. One current example of this is the Amazon Pegasus Smart AGV, which has a little section of belt conveyor on top that automatically loads and unloads product, and does the transport from the end of one conveyor system to the beginning of another conveyor system. It's being installed and actually in use in Amazon sortation systems now. Justin, let's take a step back now and talk about a different type of automation, and that of digital automation.
When we refer to digital automation, the concept is the idea of utilizing software and math-based optimization engines that don't require any new physical infrastructure. One module within our system includes dynamic work optimization, DWO for short, that optimizes how orders are batched together and how the picks are sorted for the user to execute. The batch optimization component of DWO leverages the mathematical model and knowledge of the locations of every pick within an order to effectively build batches to maximize the pick density and potential overlap of travel between the orders selected. The pick path optimization component will direct the user through the warehouse. While doing so, it will leverage cut-throughs and pick products at the end of aisles rather than traversing them completely in a traditional serpentine path. Traditionally, batches are created in some rule-based fashion. These rules could be based on priority, where priority is defined as something as simple as first in, first out, or FIFO, or something more complex, such as the earliest gate time by zone and or by carrier. What dynamic work optimization does is take these types of rules in conjunction with mathematical models of the warehouse and then apply it to an optimization problem which looks to reduce the cost of the batch. In most cases, the cost of the batch is weighted heavily by the travel distance necessary to complete the batch. However, in a situation where high priority units of work are considered, trade-offs are calculated in order to produce the batch with the best value to the warehouse. I'm going to illustrate the difference between FIFO batching, something that traditional WMS systems or other order management systems might do, and how DWO approaches batching. In a traditional FIFO approach, what you see on the screen is you would typically start with the first order that's in the queue and just select the next 5 in line to put them into a batch. In this example, the overall travel distance by putting orders 1 through 6 in a batch is 176 feet. Moving on to how DWO would handle the same situation, we would consider a seed order, which is essentially the highest priority unit of work we should consider, and put that in the batch. Based on adding order 1 to the batch, our overall travel distance is 100 feet. What we do next is looking at all the orders in the queue and considering the potential overlap with order 1 in regards to the pick path through the warehouse, we look at the incremental cost to adding every other order to the batch. As seen on the screen at the bottom, you can see that order 8 has 0 feet incremental addition to the travel path. If we add that to the batch, the travel distance is still 100 feet. Looking at all the other orders in the queue, we can see that order 6 is next in line with an incremental 10 feet to add to the batch. So we add that next to the batch. Now that we've added order 6, we recalculate all the distances because order 6 had 10 additional feet to the travel path. Now some of the distances on the other orders have changed, and so we dynamically relook at the incremental cost for adding each of these orders, and we continue and iterate through the same process. So we add order 7, and then overall, we actually may go further into the queue of work, not shown on the screen, and add order 26 and order 15. So utilizing DWO to create the batches, we actually landed at a travel distance of 138 feet, which is much better than 176 feet, roughly a 22% savings. Ron is now going to walk through the pick path optimization component of DWO.
Thanks, Justin. And as Justin said, oftentimes you can get significant benefits in a warehouse just by batching where you previously weren't batching or doing this intelligent batching that he was describing. One of our customers, before we went went in, put pedometers on their pickers, and they were walking the equivalent of a marathon every 8-hour shift. And through batching, through batch optimization, we were able to cut that almost in half. So there's some significant gains to be had there. Similar to batching, picking in a warehouse is traditionally done in fixed location sequence. Unfortunately, it usually leads to wasted movement through the warehouse. Those of you familiar with DC operations might have noticed your top pickers plan their travel a few or even many picks ahead to reduce their total travel. The second component of the dynamic work optimization module makes this planning accessible by all levels of picker by automatically searching for and minimizing travel alternatives. Additionally, the volatility that exists in the warehouse might require real-time updates to the pick path. For example, if an aisle is blocked and the picker wishes to skip that aisle, the pick path optimization will resequence or reallocate those picks from the pick list and dynamically recalculate a new path. The last point we have listed on this slide is that dynamic work optimization uses the picker's starting position and desired endpoint to create batches and determine pick path. This means that if a picker just dropped off their last assignment at a specific dock door in the warehouse, then their next pick path starts taking that location into consideration, or indeed could also include an interleave put-away task. This is one of the unique capabilities that we've designed to be a part of dynamic work optimization, which not only reduces travel time during an assignment, but also between assignments, leading to further savings. Following is a visual demonstration of pick path optimization feature. To illustrate how the tool works, we've developed this simulation tool that draws the pick path generated by the Lucas DWO tool and shows the distance saved compared to traditional location-based routing. And before I run this, I just want to let everyone know that sharing videos via WebEx isn't always super reliable for all users. So bear with me if the video is jumpy or doesn't stream well for you. When John sends the presentation slides out later today, he'll send you a link to this short video clip. As you can see in the box on the left-hand corner of the slide, the tool shows a comparison of the distance traveled using path optimization versus picking in location sequence. For each of the batches that are shown in this video, travel savings is 20 to 30%, and just assuming pick path optimization without including any benefits of batch optimization that we discussed before. Turn it back to Justin now to talk about robots.
So we're going to look at two scenarios where we can combine DWO, optimized human picking, alongside robots instead of traditional mechanical automation. In the first example, we'll look at a warehouse that has conveyor belts throughout. This example is of a 6-zone warehouse with a conveyor system that diverts totes or cartons to each of the zones and then sorts to various packing stations as seen on the left. One major drawback is that conveyor systems often cause barriers to free movement of people and equipment. They dictate the need for zones as well. In order to move around, people have to walk around the conveyor or through gates to get from zone to zone. In our revamped warehouse, we've eliminated the conveyor system altogether. As a result, we have additional cube and storage space to leverage, as seen with the dark blue bays at the bottom of each zone, which is now virtual. This also frees up the pathing possibilities from zone to zone. With this added flexibility, optimization of batches can be improved and is a great use case for DWO. As seen on the key at the bottom left, you'll see the humans in gray picking with the carts in green. Instead of the conveyor belt, the robots in red have taken their place. You'll see the robots carrying the green carts away to packing, as well as empty carts to the staging areas for pickers to begin picking. Robots are used to handle the long travel between zones, packing areas, sorters, and etc. They are not going down the aisles. The robots pick up carts and transfer them. Humans push the wheeled carts down the aisle to each location for picking as dictated by DWO. You'll notice that some of them have cut across their traditional zone boundaries as well. In summary, Lucas DWO batched the orders on the cart to reduce the travel within the picking areas for workers and leverage robots for the takeaway, which is heavy on travel. Ron is going to walk through another potential scenario utilizing DWO with robotics.
Thanks, Justin. And that's great if you can get rid of conveyors, as the previous slide showed. You have the opportunity for doing bucket brigade picking across zones. You can really boost your overall productivity above and beyond just having more flexibility with conveyors. In our final example, we're going to apply digital automation to optimize and coordinate the work of humans and robots, orchestration, if you will. This coordination will be handled by our DWO, or Dynamic Work Optimization module. Currently, the robots or AMR company's solution is to have human workers read a robot screen to know where their next action is. But in our example, the pickers will receive their instruction through headset and use voice or scanning or screens to actually confirm the picks. So we're kind of decoupling having to read the screen on the robot from being able to direct and move the pickers or the human labor around. Adding coordination and communication between robots and people will provide significant value in reducing travel and will also result in better positioning of the resources, both robots and humans. Before I start, I will again mention additional advantages of dynamic work optimization, which is the real-time batching of orders. That feature is not represented in this simulation, but could be added to the overall solution. So here a picker is directed to pick location and robot A. Once the first pick is completed, the system takes into consideration the location of the picker as well as the location of all the picks and the corresponding robots. The system directs the picker to the location directly behind them and coordinates moving the correct robot to that location, and also positions robots for future picks. Once that pick is completed, the system directs the picker and the robot to the next pick location. As you see here, the picker is directed to the pick in the next aisle instead of the robot that they could see in the current aisle, which is the current solution envisioned by the current generation of robotics. If the system detects sufficient demand, or if labor becomes available, a new worker, the little dot at the top of the screen, may be directed into the zone. As picker 1 is completing the pick to robot C to provide a more efficient pick path and distribute work among available pickers, the system has determined that robot B should be repositioned. And the second picker gets directed to robot C. Picker 1 and 2 continue to get instructions and complete their picks. Because they're directed, they don't have to scan into each robot before they pick, which is, again, the current practice. They can confirm placing the items to the correct robot or tote by speaking a check string or scanning or using RFID. And we now watch them complete their picks. as Picker 1 completes the pick to Robot B, they can be directed to another area of the warehouse, again based on the demand, because now there's not enough pick density to support 2 pickers in this area. In summary, this slide shows the travel path traveled by Picker 1 with only robot-assisted picking. The total travel distance here is represented by about 412 feet. This slide shows the path with human-robot coordinated picking, showing travel of a total of 202 feet with an over 50% reduction in human travel. And this slide shows the 2 pick paths, kind of the before and after overlaid.
So as we discussed, the travel challenge has many dimensions. Voice enablement alone is not the answer. While lean tactics can be employed as part of your travel reduction strategy, it may not be enough for you to get to your goal. Robotics and digital automation are more sophisticated methods to go after the overall travel reduction and efficiency gains your operation might be looking for. By leveraging DWO with robotics, you can keep your labor focused on picking and maximize the pick density for them. At the same time, you can optimize the use of robotics to handle the travel component for trips between areas that an order must take. Lastly, with the gains in productivity and use of robots, we can improve the overall throughput in the DC without a major warehouse redesign. With that, I'll hand it off to John to moderate our Q&A section.
Great. Thank you, Justin. Thank you, Ron. Just to repeat, if you have a question, you can type it in on the Q&A panel. We've already gotten a few questions, but we have about 5 or 6 minutes left, so I think we'll be able to get the questions that have come in. So if you do have a question, there's still time to submit it. And like I said, if you have follow-up questions or want to do a one-on-one session on the topic, you can email me at schrieffer@lucasware.com. All right, so let's go to the questions. So here's our first question, and I'm assuming this is dealing directly with DWO. Question is, what if a worker wants to skip an aisle or a location is out of stock? How would DWO deal with that?
DWO will recalculate the path. So in other words, the optimization gets rerun given that update in users' preference. So they indicate that they're going to skip an aisle, skip a slot, reverse the aisle, and the algorithm is rerun and then give them a new optimal path.
Okay, great. Thanks, Ron. So here's another one. And this, Justin, when you ran through the DWO, the batching, you were very deliberate about it. And here's a question about how quickly can those calculations be made by DWO about which orders to batch together and the pick path?
Yep. So when a user is at the beginning and ready to get the next unit of work or assignment, they will say the words "get work." At that time, DWO runs through the calculations. In order to make sure you have a seamless user experience, that actually occurs within milliseconds, probably sub 100 milliseconds. So from a user perspective, it happens instantaneously, and we have things in the system that make sure that the performance is turning around quickly.
Great. Thanks, Justin. Okay, here's another question. How will the system know the location of the people in the DC? Would they have to carry a tracker? Ron?
So right now, the system knows the location of the people in the DC based on one of 2 things. One is their last recorded pick. So they've gone to a location, they've acknowledged that they're at that location, and the system knows that they're at that location. After we get that confirmation, we then give them another pick instruction, and we are currently assuming that they're traveling to that second location. As the technologies in the warehouse advance, again, the system is based on Android smartphones that the users carry with them. So as the location, motion, directional capabilities of those platforms mature, we will be able to track more and more closely how the picker is actually traveling. But currently we're using current location and directed destination location with some informational clues along the way. So we have a fairly close idea of where they are because we know point A and point B, and as the technology matures, or if the customer chooses to instrument their distribution center, with the indoor satellite GPS systems or beacons or locators, we'll know more and more granular where they are and how they're traveling. So that's kind of the future in the next few years here.
Great. That was a good question. Here's another question, I guess for either of you, actually. What if we aren't batch picking? Can we still use this tool for pick path optimization?
Absolutely. And actually, we have done implementations where customers are batch picking today, and they see the benefit with DWO just because they've run through the numbers utilizing their own algorithms and then running through essentially the results utilizing DWO to see the before and after. So absolutely, you can use DWO just for pick path optimization or to improve the existing batching you currently have.
Great. Okay. Another batch-related question. What if product is in multiple locations? Would the tool select the location in order to optimize the batch? Good question.
So we will actually respect the allocation from the WMS. So typically we'll receive a pick location specified either in the order or the individual pick that's been passed to us. However, if the host system gives us an alternative location, we will utilize that if a user gets to a slot and tries to pick the product, but there's no product there. We're happy to take them to an alternative location to complete the pick as requested for the order.
Great. Let's see. Can we use DWO without using the rest of the Lucas solution? Ron, do you want to?
Yeah, we're actually able to utilize DWO as a module that takes in orders and sort of exports the batches. One of the key concerns we have is making sure that the user experience on the floor is clean. So that means, the execution that they're doing, whether it's on RF or a paper process, supports sort of that dynamic pick path optimization. At the same time, if you're unable to handle some of that, and especially on paper, you're not capable of that, we do recommend employing the entire work execution suite with DWO attached to it.
Great. Okay. And we had a follow-up question from earlier. Have you tested this software in a live DC environment?
Yes, we've deployed this with actually stunning results in several instances. First deployment was in 2016.
Yeah.
And our customers are, in many cases, thrilled, getting exceptional results. We had one, the supervisor challenge, where the supervisor didn't think that the computer could beat him in terms of pick path optimization. So he got his wheeled measuring stick out and measured how he would pick, and we set the system how our system would pick. We beat him by 6%. So that was the best human, and he thought he could minimize his travel path, and the computer was close, but it beat him by 6%. Typically, it was about 20% over what a kind of an off-the-shelf user or a person walking in off the street would have done in that same situation.
Right.
So he was good, but in that one instance, we got him.
Right. All right. Well, thank you, everyone, for your questions during the Q&A session. Like I said, again, we will be sending out a copy of the slides as well as a replay of the presentation. I just encourage you to share it with others in your companies who may be interested. Also watch for future Lucas webinars. They're listed on our website at lucasware.com. We host these about every 2 to 3 months, and we try to keep them fresh or new and different topics, new technologies. So we'd welcome any feedback on other topics we should cover or different ways we might present the information. Thanks again, everyone. Have a good day.